Hello and welcome. It is Thursday, January 23rd, and I am coming to you through video because I am at the dentist. Hopefully they are telling me that I have no cavities and I'm good to go. So anyway, I'm going to share what we would have done in class and run you through it, and then you can have the rest of the time today to work on your discussion. So I'm going to share this cute little, I have a pointer in here. Anyway, this little cat cartoon over here. Here's our free neutron, the orange kitty coming up to the uranium, and it splits the uranium into two. There's also in the top right corner there some examples of fusion, fission, and fashion. And just in case you can't see that, turn my video off. I thought that was pretty cute. All right, so I was mistaken. See, I thought this was on Friday, but look, here it was in my PowerPoint from Thursday. So I want you to pause this, see if you can figure this out. Don't forget about the neutrons, and then push play once you have figured it out. All right, answers coming now here in 3, 2, 1. All right, so what I did to figure this question out is I looked. Let's see if I can annotate. Okay, so I looked here at my reactants and figured out that that was 1 plus 235, which is 236. And then I looked at my products mass. So I've got to look at the whole thing here. And I've got 3 neutrons, 1, 2, 3. 141 for the mass of barium, and krypton is our unknown, so I put in the Kr there. And a little bit of algebra, subtract 144 from both sides, and boom, you get 92 AMU. So if you have questions about this, just go ahead and open up an email and type your question in there. Even if it's, I don't get this, can you please explain it in more detail? I can do that for you. Clear all drawings. And then I have a second question to do today, which was balancing the equation with the dots. So go ahead and pause the recording and figure this out, and then play it back when you're ready to go, and we'll check your work. So I'm going to tell you the answer here in 3, 2, 1. Okay, so here was our answer. Hopefully you got this one right. I will give you a round of applause in case you did. And if you did not, then let's see here. I'm going to go through and show you how to solve it. So I start off with the reactants. I've got 2 of the small white circles, and I have 2 of the big red circles. In the products, I have 2 of the little white circles and 1 great big red circle. And so to balance these, I need to increase my reds over here in the products. So I'm going to put a 2 as a coefficient there. And let's see, can I change my color? Oh, I can. Okay, and so if I put a 2 there, that distributes to all the atoms in here. So now I have 4 of the little white circles, and I have 2 of the big red dots. Okay, so now our little white circles don't balance out. because they have different masses. I've got 2 over here and 4 in the products, 2 reactants and 4 in the products. So I'm going to have to do something to this 2 to make it into 4. I'll have to put a 2 there. So 2 times 2 is 4. And then we are all good to go. The blanks get a 1. And so our answer is 2, 1, 2, which is our smiley face. And again, if you had any questions or don't know how to do this, please open up that email and send it on to me. Send me your questions. Oh, let me stop annotating so I can go on. All right, so our objectives today is that you can conduct research about application benefits and problems of using fission and fusion to create electricity. I have given you some specific websites, and then also that you can discuss this research with your peers. And then we did the review, or there's the standards. Oh, and the GIF in here is the picture of a nuclear fission reactor. It's surrounded by the water there, and you can see it boiling the water very nicely. Okay, so it's something for you to think about. The differences between fission and fusion. So if you want to think longer, go ahead and pause the recording. All right, some differences are, of course, in the products here. Annotate. Draw. I'm so not used to using Zoom. Okay, so in fission, we end up splitting the atom. We get 2 products, whereas in fusion, you only get 1 product. So that's when it kind of fuses together, and you get 1 larger nucleus. The fusion has much greater energy, 3 to 4 times as much energy. The waste is helium here in fusion, and the waste in fission is actually radioactive. Let's see if I can draw that radioactive little symbol. That's probably not it, but hey, maybe it gave you a good laugh today. Anyway, so there's some differences. Oh, we can do fission on Earth very easily, and fusion is very difficult because it needs a lot of high temperatures and pressure. And I bet you maybe thought of some additional differences. You're welcome to email them to me if you want to. Let's see, what's next? Okay, which one do we use to generate electricity? And if you said fission, you are correct. We do generate electricity with fission. 10 to 20% of our electricity energy does come from fission. In fact, there's a brand new nuclear plant they're almost done building here in Georgia. It's called Plant Vogel, and it's down by Augusta. So we're about to have more energy due to fission here in Georgia. So why can't we get fusion to generate electricity? Why can't we use it? And the reason we can't use fusion, and pause this if you need more time to think, fusion requires extremely high temperatures, extremely high pressures, and an extremely expensive magnetic field generator contraption machine to hold that fusion reaction. And it's just not economical to do here on Earth yet. But if you can figure out how to do fusion that's at lower temperatures, you will be rich beyond belief, and we will have unlimited electricity forever, clean energy. So all this leads us to our nuclear energy discussion today, and that's today's assignment. So you're going to head over to Canvas, and I think this annotate has a spotlight. It does. That's so cool. Nope, spotlight. Let's try that again. Yes, it has a spotlight. So head over to Canvas, find the nuclear energy discussion. There's the little nuclear symbol that looks like a flower, but it was actually the nuclear symbol. So anyway, you're going to read the post, follow the links, read about it, decide what you want to do for your post, and then you're going to post, and of course reply back to 2 of your peers very graciously, and all the directions are in there, so I'll let you read about it. I also have posted this PowerPoint in Canvas under the assignment, so you'll be able to also see all these breakout rooms, and the links will work. So these would have been breakout rooms we would have used today. If you want to go back and review some current and past vocab, maybe for tomorrow's vocab quiz, might be good. Practice with isotopes. This is a great PhET practice of the periodic table and elements, neutrons. And then this is a great little game that could help you with understanding the fission and fusion. It's adaptive, so if you get them right, it gets harder. If you get them wrong, it gets easier, so that it helps you to learn. Kind of like, I don't want to mention those math tests, that it's kind of like, anyway. And that's it. So the rest of your time today is to get that discussion done, and I will see you all tomorrow with some nice, clean, sparkly teeth. Have a great afternoon, and please email me if you have any questions. How do I turn this off? There it is. Stop recording. Bye.